As the question says, let m1 equals to 1 kg, m2 equals to 2 kg and m3 equals to 3 kg in figure. Find the accelerations of m1, m2 and m3. The string from the upper pulley to m1 is 20 centimeters when the system is released from rest. How long will it be taking before m1 strikes the pulley? Now let us see how we will be proceeding in this question. Since they has asked us for the accelerations, we will be drawing the free body diagrams for all the three blocks and will be solving for the accelerations. Further, they have asked us how long will it be taking. So in this part, we will be simply employing one of the three equations of motion because we will be having accelerations by that time, and they have also given us the displacement that is equal to the length of the string. So let us proceed in the question, marking these as block 1, 2 and 3 respectively, taking the acceleration a3, a2. Then obviously the upper string will be moving with the acceleration of a1. So the block m1 will be moving down with an acceleration of a1. Further, taking the tension T in the lower string, so obviously it will be 2T in the upper string. Now let us proceed with block 1. Drawing the FBD for block 1, we are having a block of mass m having an mg force in downward direction, a tension of 2T in the upward direction and an acceleration of a1 in the downward direction. Framing the equation for this block, we can say ma1 equals to mg minus 2T. And we are having the value of m equals to 1 kg from the question. So putting the values over here, we can say a1 equals to g minus 2T. And marking this equation as equation number 1, let us proceed to block 2. Again, drawing the free body diagram of this block, in which we are having a block of mass m having an mg force in downward direction, a tension T in upward direction and an acceleration of a2 in the downward direction. Framing the equation, we can say ma2 equals to T minus mg. Putting the value of m equals to 2 from the question, we get twice of a2 equals to T minus 2g. And marking this equation as equation number 2, let us proceed with the block 3. Drawing the free body diagram for this block, in which we are having a block of mass m having mg force in downward direction, a tension in the upward direction and an acceleration of a3 in upward direction. So we can frame the equation as ma3 equals to T minus mg. Putting the value of m equals to 3 kg from the question, we can say thrice of a3 equals to T minus 3g. Marking this as equation number 3. Now, removing T from equation number 2 and equation number 3, we can say that twice of a2 minus thrice of a3 equals to g. And marking this equation as equation number 4. Let us put the value of T in equation number 1 from equation number 3, and let us remove a1 from this equation also by the pulley equation, which we have learned earlier, that is in the previously done questions. We can say from this pulley number 2 that twice of a1 equals to a2 plus a3. So let us put all these values into equation number 1, that is g minus twice of thrice of a3 plus 3g equals to a2 plus a3 over 2, that is giving us the equation minus 10g equals to a2 plus 13a3, and marking this as equation number 5. Now, if you notice carefully, we are having equation number 4 and equation number 5 in two variables a2 and a3. So, let us solve equation number 4 and equation number 5 to get a3 equals to minus 21g over 29 and a2 equals to minus 17g over 29. Now, putting both of these values in our pulley equation, we can also find a1, which is coming out to be minus 19g over 29. Now we are having minus sign in each of these accelerations, which implies that this M3 block is actually accelerating in downward direction. This M2 block is also accelerating in downward direction, while this M1 block is actually accelerating in upward direction. So we have done the first part of the question. Let us now move to the second part of this question. Since the system is released from rest, we are having initial velocity of block 1 equals to 0. Acceleration we are having 19g over 29 in upward direction, and we need to find out the time when the displacement has been given 0.2 meters. So let us employ the second equation of motion, right? S is equals to ut plus half a t square. Putting the values in this equation, we get 0.2 equals to 0 plus half into 19g over 29 t square, getting t equals to 0.25 seconds. Note, we have taken g equals to 10 meter per second square in this equation. Note, in such type of questions, that you first strategize, that make sure what actual process you will be following to solve this question. Further, in all these questions, take care of the directions, otherwise all of the equations will change and you will be resulting in losing most of your time.